Hello, everyone. In this lesson, my objective is to show exponential functions and the translations that will take place on the exponential function by changing the numbers. So, first of all, before this, even we start this, I want to cover some prior knowledge that is required. So, we see that my x is in an exponent spot, so that's why we call these as exponential functions. And you need to know what an asymptote is. We need to know what x-intercept, y-intercepts are. And then I want you to understand the effects, like what is the vertically shifting up, like reflection across x-axis, and then moving across there's a shift, vertical shift and horizontal shifts. And then we're also going to see what happens when I increase the base value of the equation. So we're going to talk certain words, but just I'll slow down when those words are coming up so it's much easier for you. So let's start comparing some exponential functions. All right, so I'm introducing a new equation which is y equals 3 to the power of x. So what do you see compared to the red curve and the blue curve? So we can say that as I increased the base value, right, the curve got more closer to the y-axis. So let me increase the base value as maybe 10 to the power of x. So as we increase the base, the curve gets closer and closer to y-axis. But in all situations, you can see that the y-intercept is 0, comma 1, and it always has y values greater than 0. So they're all positive. Even if you increase the x values, you can see that the y is getting way steeper. It's getting more closer to y-axis. And then the asymptotes, they all have the same asymptotes, which is the x-axis. It's acting like a barrier. It doesn't allow any of the curves to pass through. So the equation of x-axis is y equals to 0. So that's what we can say. So this is what we are looking at in comparing the exponential curves. So now what I'm going to do is I'm going to introduce a new curve, which is, I want to show you the first, we'll start with vertical shifts. Okay, so all I have to do is y equals, I'm going to write 2 to the power of x, but I'm going to put plus 3. So as you can see that the same curve has shifted by 3 units up. So your new y intercept is now at 0, comma 4. All right. So let's see what happens to the curve as it approaches to the negative values. So what can I say about its asymptote? Can you think of its asymptote? As I increase the x values, so right now at this particular spot, which is x equals to 3, sorry, y equals to 3, my bad, I'm sorry. So the y equals to 3, because even if this whole thing disappears, right, when x is 0, um sorry, when x approaches infinity, so this whole piece disappears. So y equals to 3 is acting as your asymptote, so the curve will not pass beyond this point. All right, now let's check the other one. Shift down, vertical shift down, so 2 to the power of x, and then come out minus 3. You can see that your new asymptote is at negative 3. The curve doesn't pass beyond this point. And then your new y-intercept is 0, comma negative 2. So your y values are always going to be greater than negative 3. Okay, so as the x increases, you can see that the curve is going up. It's going to have a higher values of y. But what is the lowest point that it can be? The lowest point is when y equals negative 3. So, and also y equals negative 3 is acting as your asymptote. The curve doesn't go beyond this point. All right, guys, so we covered vertical shift. So now let's take a look at something called as reflection across x-axis and reflection across y-axis. All I'm going to do is make this to a negative 2 to the power of x. So as you can see, it's the same curve, but this time it is as if there is a mirror that made it reflect towards the negative region of this xy plane. So your new y-intercept is at 0 comma negative 1. It's touching the y-axis at negative 1. And as you can see, the asymptote is still going to be the same x-axis. So the equation of this asymptote, if it is asked, you have to say the equation of x-axis is y equals to 0. All right, so it does have a horizontal asymptote, which is the x-axis, and equation of that line can be written as y equals to 0. And as you can see, we can say the significant features of this curve the same. As you keep increasing the x values, this time you see that the y values are taking over to the negative infinity. So it gets a higher negative y value. So basically, the y values are decreasing. In other words, as increases, the y is decreasing. So those are some significant features that we can talk about this particular equation. So one more thing I'm going to add. I'm going to add something called as, or maybe this one, y equals 2 to the power of, this time I'm going to make the exponent negative. So this one looks like as if there is a reflection on y-axis. If you place a mirror on this y-axis, you can see that it's reflected. So this is called vertical reflection across y-axis. And in both scenarios, your y-intercept is 1. Okay, but you have to, the significant features change. The asymptote still stayed the same, which is the x-axis, but as the x value is increasing, the y is approaching to 0. You see, it's the description changed. Early for this one, as the x increases, for the red curve, as the x increases, the y is taking up a high value, a higher values of y. Okay, as if it's approaching a positive infinity on y. But for the blue one, you have the infinity y is increasing only for lower x values. So when x is on the negative axis, the x values are on the negative side, you have a high y value. But as the x values are increasing, the curve is tending to approach to 0. Again, this is your x-axis. This is acting as an asymptote. It doesn't allow the curve to pass beyond this point. So the equation of this asymptote, this horizontal asymptote, is y equals to 0. So these are some significant features. All right. Finally, I'm going to do one last equation, and I want to ask, pause the video and can see if you can describe this. Okay, so we will start like this. 2, I will say I'll put negative 2 to the power of x plus 1. So what just happened here? What can I talk? What can I describe this curve to be? You can pause the video, think about it, and then describe the situation here. So, what are some significant features that you have noticed regarding this curve? Now, this curve, the green curve, you can see that the intercept is now at 0. Why is that? For y-intercept, you have to set the x value to 0. So negative 2 to the power of 0, anything to the 2 to the power of 0, this has become 1, but it's a negative 1. So negative 1 plus positive 1, this whole thing has now become 0. So that's why your y-intercept is the origin. And also, you can see that the asymptote, let's talk about the asymptotes. The equation will never pass beyond y equals 1. as you can see, the highest value that it will have is 1, and the y values are all less than 1 after that. Okay, so what can you talk about the y values? Equal to 1 or less. All these points below, that is what the curve is taking in. What else can we describe? We can describe that as the x is increasing, the y is decreasing because it's going towards the negative infinity. So these are some features and words that I want you to use in your sentences in describing the exponential curves. All right, I hope this is helpful when you're comparing the exponential functions to the original function. So here I can say that my original parent function was y equals 2 to the power of x, and I have done different variations to this. I shifted it vertically up, vertically down. I made it reflect across x-axis, reflect across y-axis, and then we talked about what would happen if I do a combination of reflection and a shift. All right, guys, I hope this video is helpful. And please make sure that you watch the other videos to know more details of the parent function and how the graph is done. I can only talk about it on this particular website, but to know more about the details, check out the other videos. And once again, thank you, Desmos, for your graphing tool. This has been quite helpful to teach kids about the effects that any of the nonlinear graphs or linear graphs would take place. Would it happen on a vertical shift, horizontal shift? So thanks again for your free graphing tool. Thanks, guys, for watching.